The fix worked. 3 files that never opened are now broken. Nothing failed. No warning. This is the most common way AI touches a real code base, and it's one of 5. Sorted from the one you notice to the one you don't. Every item comes with what to do instead. None of them require you to use an agent daily. They show up the first time you point one at code that already exists. And they all share one cause, which is not the model and not what you expect. That comes at the end. Cross-file dependency is where agents break down hardest. Benchmarks on agentic refactoring keep landing on the same bottleneck. The agent edits what you pointed at. It does not open every caller, every subscriber, every test that assumed the old shape. Your compiler catches some of it. Reflection, dependency injection, string-keyed lookups, and serialized contracts catch none of it. So make the blast radius part of the request. Have it list every caller before it edits anything. 2 words change the outcome. Who calls, and they cost you nothing. If the list comes back short in a codebase you know is tangled, that's not a clean bill of health. That's the size of the window it searched. Here's a finding that surprises people. Agents perform STEM or more refactorings than human developers. They also produce less structural improvement. Renamed variables, extracted one-line methods, reordered imports. Real edits, no architectural effect. The diff looks like progress. The design is exactly where it was. Why does it do this? Because shallow edits are safe edits. Renaming a variable can't break a contract. Moving a boundary can. Left alone, an agent optimizes for changes it can verify, and it can't verify an architectural decision, so it doesn't make one. Judge a refactor by what got simpler, not by how many lines moved. One useful question after every cleanup. Did any file get deleted, or did they all just get rearranged? The Gaddy. What happens if you let it fix only the file in front of it? It solves the symptom locally and adds a second source of truth globally. A cache here, a null check there, a helper that duplicates one. You already have 2 folders away. Each edit is defensible alone. Together, they're architectural drift, and nobody reviewed the direction, because nobody was asked about the direction. The tell is duplication that arrives quietly. 2 functions that mean the same thing with different names, in different folders, written weeks apart. Nothing is wrong today. In 6 months, nobody knows which one is authoritative, and both have been edited. The dangerous output is not the one that crashes. It's the one that looks like your code, uses your naming, passes your build, and assumes something your system never guaranteed. Ordering that isn't ordered. Nullability that isn't enforced. A time zone nobody declared. It reads as senior work, and confidence is the one signal you cannot use to grade it. Only one thing grades it. A test that failed before your change and passes after it. Not a test written after the fact to match the code. That one passes by construction and proves nothing. Write the assertion that would have caught the bug, watch it go red, then let the change turn it green. Every agent reasons only over what fits in its active memory. Your system does not fit, so it works from a window, a few files, a summary, whatever it retrieved, and it cannot tell you what it didn't see. That's the part people miss. You don't get an error for missing context. You get an answer written as if the context was complete. The bigger and older your code base, the more of it is outside the window on every single call. The tell, if the answer never says I didn't see this part, you don't know what stayed outside the window either. All 5 are real, and the fixes still apply, but they're symptoms. Here's the disease. Research keeps finding the same thing. Agents fail hardest where the code itself is unhealthy. Tangled dependencies, oversized files, unclear boundaries. Give the same model a clean module, and the failures mostly disappear. The bottleneck is usually the codebase, not the model. And here's the mirror. Everything that makes a codebase AI ready, small files, clear seams, explicit contracts, tests that fail loudly, is the same list that makes it readable for the developer who joins next year. You were never optimizing for the machine. The machine just audited you faster than any code review ever did. So, it edits what it didn't read, calls renaming progress, fixes locally and drifts globally, sounds certain while being subtly wrong, and never tells you what fell outside its window. Screenshot the 5, then run one experiment tonight. Give your agent the same small task twice. Once in your messiest file, once in your cleanest one. No agent yet? Then, the first time you open one, start in your cleanest file, and watch what it gets right. The gap between those two results is not a fact about AI. It's a measurement of your codebase, and it's the most honest code review you'll get this week. Tell me which file lost.